Good day. I am Shanae Villaflor, and our group will be discussing about innate immunity response for phagocytosis. And here is Jessa Ocero to discuss about natural or innate immunity.
Natural or innate immunity is the ability of the individual to resist infection by means of normally present body functions. These are considered non-adaptive or non-specific and are the same for all pathogens or foreign substances to which one is exposed. No prior exposure is required, and the response does not change with the subsequent exposures. Many of these mechanisms are subject to influence by such factors as nutrition, age, fatigue, stress, and genetic determinants. The innate defense system is composed of two parts: the external defense system and the internal defense system. The external defense system is designed to keep microorganisms from entering the body. If these defenses are overcome, then the internal defense system must clear invaders as quickly as possible. Internal defenses can be categorized into cellular mechanisms and humoral factors. Both of these systems work together to promote phagocytosis, which results in the destruction of foreign cells and organisms. The process of inflammation brings cells and humoral factors to the area in need of healing. If the healing process is begun and resolved as quickly as possible, the tissues are likely to be damaged. We'll tackle first about the external defense system. The external defense system is the first line of defense. It is composed of structural barriers that prevent most infectious agents from entering the body. First and foremost is the unbroken skin and the mucosal membrane surfaces. To understand how important a role these play, one has only to consider how vulnerable victims of severe burns are to infection. Not only does the skin serve as a major structural barrier, but also the presence of several secretions discourages the growth of microorganisms. Lactic acid in sweat, for instance, and fatty acid from sebaceous glands maintain the skin at a pH of approximately 5.6. This acid pH keeps most microorganisms from growing. Additionally, each of the various organ systems in the body has its own unique mechanisms. In the respiratory tract, mucous secretions and the motion of cilia lining the nasopharyngeal passages clear away almost 90% of the deposited material. The flushing action of urine, plus its slightly acidity, helps to remove many potential pathogens from the genitourinary tract. Lactic acid production in the female genital tract keeps the vagina at a pH of about 5, another means of preventing invasion of pathogens. In the digestive tract, acidity of the stomach, which is due to the production of hydrochloric acid, keeps the pH as low as 1 and serves to halt microbial growth. Lysozyme is an enzyme found in many secretions such as tears and saliva, and it attacks the cell walls of microorganisms, especially those that are gram-positive. In many locations of the body, there is normal flora that often keeps pathogens from establishing themselves in these areas. This phenomenon is known as competitive exclusion.
And now, we go on to the cellular defense mechanism and complement system to be discussed by Jonalyn Velasco.
Internal defense system is designed to recognize molecules that are unique to infectious organisms. White blood cells seek out and destroy foreign cells by participating in phagocytosis. Phagocytosis is enhanced by soluble factors called acute phase reactants. Cellular defense mechanism. The process of phagocytosis in internal defense mechanism includes 1. Physical contact between the white cell and the foreign particle. 2. Formation of a phagosome. 3. Fusion with cytoplasmic granules to form a phagolysosome. And 4. Digestion and release of debris to the outside. The three main groups of phagocytes are monocytes and macrophages, granulocytes, and dendritic cells. Monocytes. When a tissue is infected or inflamed, they may leave the bloodstream and enter the tissue, while macrophages are derived from monocytes and are found in the tissues. They play a role in phagocytosis of cellular debris, microbes, and any other foreign substances. They are termed differently depending on their location. Microglia are present in the CNS, and Kupffer cells are in the liver. Dendritic cells. Immature dendritic cells travel in the bloodstream and migrate through tissues and continually sample the pathogens they find via micropinocytosis. Granulocytes includes eosinophils, basophils, and neutrophils. Neutrophils are the most abundant of white blood cell. They are formed from myeloid stem cells found within bone marrow. During the acute phase of infection, they are among the first inflammatory cells to reach the site of infection. They are short-lived cells and normally die following phagocytosis and use of their granules. They induce inflammation and recruit inflammatory cells through release of cytokines and other inflammatory factors. Complement system. It enhances the ability of antibodies and phagocytic cells to clear microbes and damaged. It recruited and brought into action by antibodies generated by the adaptive immune system. It consists of a number of small proteins that are synthesized by the liver and circulate in the blood as inactive precursors. Proteases in the system cleave specific proteins to release cytokines and initiate an amplifying cascade of further cleavages. End result of this complement activation or complement fixation cascade is stimulation of phagocytes to clear foreign and damaged material, inflammation to attract additional phagocytes, activation of the cell-killing membrane attack complex.
Acute phase reactants are normal serum constituents that increase rapidly by at least 25% due to infection, injury, or trauma to the tissues. It plays a role in initiating, amplifying, or sustaining the reaction. 4 cardinal signs or clinical symptoms are redness, swelling, heat, and pain. The process of inflammation are increased blood supply to the infected area. It increased capillary permeability caused by retraction of endothelial cell linings to the vessels. The migration of white blood cells to the surrounding tissue. And lastly, the migration of macrophages to the injured area. The following are the proteins involved in acute phase reactants. C-reactive protein or CRP acts somewhat like an antibody as it is capable of opsonization or the coating of foreign particles, agglutination, precipitation, and activation of complement by the classical pathway. Serum amyloid A, it is associated with HDL cholesterol and is thought to play a role in metabolism of cholesterol. Complement is a series of serum proteins that are normally present and whose overall function is mediation of inflammation. Mannose binding protein or MPB, also called as mannose binding lectin, is a trimer that acts as opsonin, which is calcium dependent. The alpha-1 antitrypsin or AAT, which acts as a major component of the alpha band when serum is electrophoresed. Haptoglobin. Its primary function is to bind irreversibly to free hemoglobin released by intravascular hemolysis. Fibrinogen is the most abundant of the coagulation factors in plasma, and it forms the fibrin clot. Ceruloplasmin is the principal copper transporting protein in human plasma, binding 90 to 95% of the copper found in plasma by attaching 6 cupric ions per molecule. For the clinical application, natural or innate immunity causes inflammation in the body, in the phagocytosis, and action of natural killer cells. Inflammation can be defined as the body's overall reaction to injury or invasion by an infectious agent. Each individual reactant plays a role in initiating, amplifying, or sustaining the reaction, and a delicate balance must be maintained for the process to be speedily resolved. The four cardinal signs or clinical symptoms of the inflammation are redness or erythema, swelling or edema, heat and pain, in which its major events are already discussed in the acute phase reactants. Also, phagocytosis. Its main purpose of the inflammatory response is to attract cells to the site of infection and remove foreign cells or pathogens by means of phagocytosis. Although the acute phase reactants enhance the process of phagocytosis, it is the cellular elements of the internal defense system that play the major role. Once the WBCs are attracted to the area, the actual process of phagocytosis consists of 7 main steps. Number 1. Physical contact between the WBC and the foreign cell. 2. The outflowing of the cytoplasm to surround the microorganism. 3. The formation of a phagosome. Fusion with lysosomal granules with the phagosome. 5. Formation of the phagolysosome with the release of lysosomal contents. Digestion of microorganisms by hydrolytic enzymes. 7. Release of debris to the outside by exocytosis. And for the last clinical application, the action of natural killer cells. NK cells represent the first line of defense against cells that are virally infected, cells infected with other intracellular pathogens, and tumor cells. These cells have the ability to recognize any damaged cell and to eliminate such target cells without prior exposure to them. In addition, NK cells release various colony-stimulating factors that act on developing granulocytes and macrophages. Actions of NK cells, therefore, have a major influence on both innate and adaptive immunity. And that ends our presentation for natural or innate immunity response for phagocytosis. Thank you for listening. Goodbye.